would prefer that you actually interrupt me and not let me just keep talking and ask me something about um, like 5 minutes ago. So here's a pretty typical kind of differential equation. And so equation with a derivative, and I'm giving some point. And so the couple things to keep in mind, and I want to show how if they're going to give two questions, and you've done some practice with the differential equations in terms of those AP questions, or you should be finishing those. But they could like take pieces and put that together and make it longer, right? If they're going to say 25 minutes for one question, then it's possible that if one of those was a differential equation, if I was writing the test, what I would do is take components that were in different years that maybe were around the idea of differential equations and put them together in a little bit longer question. So that's what I have here is just kind of the biggest ideas around differential equations to if this is a question, and again, I have no idea, except I know that this is a typical free response question over the last several years. So the first thing is about creating the slope field. And so usually what they'll do is they'll give you points, and you saw one of these or should have saw one of these. I did a video that was about this, that they'll give some points here, and you're supposed to use the XY coordinates of that point, put it back here, and to draw some little segment that then would correspond to what the slope of the tangent line would be at that point. And so you would get, whatever it looks like. I'm not even going to try, but whatever these are. And usually you could use like the grid on the screen, like if the slope is supposed to be 1, you could try to make it look like it's 1. If it's supposed to be 2, again, you kind of use the grid to do that. If it's something in between, just make it look kind of in between. Don't spend too long on that, okay? So the bigger idea is that when we're thinking about this, this is one of the most common errors involving the slope field, is that if I had a slope field and if I see patterns that look like this, and then that pattern would be repeated up and down, and I fill this all in and get this pattern. The solution to the differential equation is the connect the dots. So when I look at this connect the dots, I see something that kind of looks like an x squared plus some constant. Maybe that constant's 3. It doesn't matter what that is. But that is the solution, which means the differential equation, the equation I would have started with that would have made these little segments should have been the derivative of this. So that would have been something like 2x, okay? So the solution to the differential equation is connect the dots. Now, we talked about the general solution to the differential equation, and that's when I find this antiderivative and I end up with something like a plus c. And so in this problem, it's not as simple as that. And so if I would say solve, I would say find here I'm looking for some specific solution because we're going to be able to figure out the c. We're going to figure out what the shift here is, whatever point that's supposed to go through. So we have one strategy, if you have a differential equation with x's and y's in it, you have one strategy. You have to separate them. You got to get them on the same side. This is that step of dy dx equals 2xy. You're going to have this point. You're going to try to get the y's over here and the x's over here. Then you're going to integrate. Now, I'm going to say this, and then I'm going to split you up here and just have you finish this problem. But the next piece that's critical, and some people messaged me this week because you were struggling with this. You were getting answers like in the AP classroom, like if you were getting answers of like 5 plus e to the tangent of x, and you're supposed to be getting answers of 5 times e to the tangent of x, it had to do with a mistake right here, okay? So if you integrate this, get the x's on the same side, integrate, and whatever you're about to write, as soon as you write this antiderivative, you need to include plus c. Don't manipulate it, don't rearrange it, don't do anything like that. And then I'm saying solve for c right now. Now, on that question in the AP classroom, what was happening is you had something like this, the natural log of so we're going to find the antiderivative. You had a 1 over y here. I think there was like a secant squared x here, something like that. So you wrote, or should have written something like that. Now, when I'm solving this for y, this base here is e, and this is what it's equal to. So it ends up being e to the tangent of x plus c. The plus c, the constant, ends up in the exponent, not off to the side, not a plus c just here off to the side like you typically think about it. So if you don't write plus c as soon as you find the antiderivative, you will occasionally get the wrong answer depending on how you need to solve for y. So in this one, again, I'm saying you can put the c there and then solve for c here in a minute, but I think it's best if you have a point. That's not the point for this problem, but to solve for c in that step and then rearrange it. And so in this problem, when you solve for c, I think you got 5. And so this ends up being 5 here. Or no, I'm sorry, I think that was the natural log of 5 when you solve for it. And then so you would get e to the natural log of 5, separating this back out, e to the tangent of x, and that's 5. And that's why it ends up being multiply, not addition. Okay. So solve for c as soon as you can, then solve for y, then rearrange and go from there. So I'm going to stop there, and before I show some of the extensions, any question on anything I said here for these big ideas?
I have a question. Oh, sorry.
Oh,
But
you go.
it was more about the like how you gave the example of like the x squared plus 3 or whatever, and then the derivative of that was 2x, like right at the beginning.
Yeah, tell me more about that.
I don't understand. So the solution to the differential equation would be the x squared plus whatever.
Yes.
So then what is the dy dx? Like, I don't understand what that's
So
for.
this is the slope at every point. So if you said here x equals 2, let's not say 2, 3, then that says the slope when x equals 3 is, so plug in 3, 6. So that means that when you think about the slope field, whenever x is 3, anywhere along this line, we should have segments that would have a slope of 6. So these should all be the same, where every slope of them is 6.
So would that be like if we had to draw?
Correct. That's one possibility. I'm going to show another possibility here in a minute. But Katie, when you think about here, like if the differential equation is 2x, and x then is -3, well, wouldn't the slopes all be -6? And then if x is 0, aren't all the slopes 0? Can you see that this would be making a parabola shape because there's symmetry on both sides? And so that's the key, that the differential equation is linear, but the pattern we see when we look at it will be the antiderivative of that original differential equation.
Okay.
Somebody else had a question.
Yeah, I was gonna ask about like for the separation. I saw in the answers or whatever for the other FRQs that you'd get a lot of like the points for the separation, but how far into like that process do you have to be in order to get those points, if that makes sense?
Yeah, a lot of those FRQ scoring guidelines will say 0 points if you don't separate. And so really, if you don't take the separation step, they give you 0 because again, we have one strategy, and if you try to do something else, then you're trying to make it up. Then you just need to look at the scoring guideline because it'll say like 3 points for finding both antiderivatives, a point for finding the correct constant, and then a point for the answer. Like sometimes those are like 6 points, 5 or 6 points for that. So I would just say once you have separated, look at the other pieces there to decide how well you did on it.
Okay.
Anyone else?
I also have a question.
Sure.
So, on the AP Classroom assignment for AB with differential equations,
Yes.
some of them only come up with like let's see, what question is this one? I don't even know. But the question, let's see if I can pull it up on my screen. Control background, none, close. All right, so let's see if you guys can see this. No, wait, no, it's turned on my face. It's cool. Yeah, right here. It says if dy over dx equals 2y squared. So like what do we do if there's, for instance, no x in the actual equation?
So just think that you could always have like a polynomial, which is what you're thinking, x, but there could just be a coefficient. So it's still a separable differential equation because here, like we could say, let me rewrite it this way. So if I would say 1 over, no, let me do this instead. So if I just said y squared is dy dx, you still need to get these y's with that dy. So I could say y to the negative 2 dy, but you could always think that there is a coefficient here that you don't have to move, which means this is really 1 dx. And then so when you integrate, there's going to be an x and then plus a c. Increase the power by 1, divide by the new power. So we could have something like that.
Thank you.
Yep. Yeah, so think as soon as they write a differential equation with y's in it, whenever this variable matches this variable, and that's really the issue I think with the potato question, is that they write dh dt, and then over here they had like a, I don't know, there may have been a coefficient here, but the key is this variable is this variable, which means it's really identical to what I'm saying here, which means if you're going to get that answer, you got to get those variables together, which means looking at this has to be like y, and then this is like the x that you're used to.
Do they
Okay, go ahead.
ever make questions where it's like dy dx equals 0, and then when you integrate, you have the c value, and then that's like a constant?
I suppose they could, Nick. I think they also want to see if you can find some antiderivative, so I doubt if they will, because that's when
Okay.
they're going to see, oh, do you know the antiderivative of 1 over y is that natural log, right? So they're going to try to test two things at once, so they probably won't ask that.
Okay.
So here's then the last piece. So how about this? I'm going to give you a minute in a breakout room, and what I want you to come up with, talk through it with each other. I want you to come up with the specific solution, the particular solution, the y equals something with x's in it plus a number that would satisfy this differential equation. Okay, so I'm going to put about 6 of you in a room. So take just a minute.
Do you want us?
Go ahead, Maya.
Do you want us to? Do you want us to find the specific equation with the 0.2 negative 1, or just the general?
Yeah, so find it with the 0.2 negative 1. I think I chose it so that it should be an easy C value. I hope you were able to get it finished. My work should be on your screen. And so, so separate, antiderivative. And so again, if you wouldn't do that, that would be the 0 credit um, on most scoring guidelines. Then we are finding that antiderivative here, substituting the point. I think it's 3, if I did that right. And then and then end up with something like this.
Isn't it -3?
-3, sorry, -3. Yep, so that's 4, that's 1, so that's a -3. And then, so you should have had this, but then you'll need to, usually they'll want it solved for y, so usually it's not that hard. So then rearranging that, so that would be the answer. Okay. Now, last bit, and then we're done. So I want you to think about how this can be extended. And so I could ask you to find the equation of some tangent line on this curve that we just found. So I could say, find the equation of the tangent line at the point, and I could name something, 3 comma something. And so what you would do is think about what you need for every equation with a tangent line. You need a point. I'm going to give that to you, and then you're going to need a slope. Now, if I don't tell you the y value, we're going to need to look down at our answer. Where do I put that? Way down here. We have to substitute in the given x and then solve for y. The next thing is we're going to need a slope. And what's the easiest way to get a slope?
Take the derivative.
And it's easier because I don't need to take the derivative of that piece, because why?
You have the differential equation.
I have the differential equation back here, so I just need to substitute that in and then get that slope. And then we could use something like point slope and say m times x minus x1 plus y1 and get our answer. The other thing to think about is that this comes up, is finding the second derivative. And so we're really now taking this differential equation and taking its derivative. Now again, if I was writing an AP test for you, when I can only give you 2 questions and one question will be a little bit longer, I would like to ask this question because it it gives me a lot of information then about the things that you know or the things that you don't. Because if I want to find the second derivative, I definitely have to be thinking implicit. But what is the other thing I have to think? And if I don't think it from the very first step, wrong answer for the second derivative. Very first step, very first thought. Before I think implicit differentiation, what do I have to think?
Product rule.
Product rule is right. So I'd have first derivative of the second. That's something squared, so the derivative of anything squared is 2y something the first, except my something is not x, it's y, so dy dx, which means this answer here for this original portion gets substituted in. So that's first derivative of the second plus second, no dy dx there because that's just the second, not the derivative, times the first. And then so clean that up, but then I could ask you a question built into this about concavity. So I could say something like this, and I want you to try to answer this. So if x equals 0, so does the graph of y equals f of x, or is the graph, I should say, of y equals f of x concave up or concave down? So look at the second derivative and tell me. So again, we have the piece, so then we don't want to start back over. It's sitting right here. Concave up, concave down at x equals 0 for y, which was this answer down here, which I'm not even going to go to. A function is concave up if what's true in terms of the second derivative?
If it's positive.
if it's positive. So look at this. When x is 0, will that be positive or negative?
Will it be positive because it's y squared?
So this piece, good Katie, this piece here is always positive, unless the only wrinkle, like this part's gone, right? Because if x is 0, this whole thing drops out. The only thing we want to be sure is that we don't want y to be 0, right? Because if y is 0, then we're at really maybe like a point of inflection then, right? So we'd be having this second derivative 0, but that piece is definitely not negative. So if I'd say, is it ever concave down? The answer is no. Or at least, is it concave down at 0? The answer is no. Is it concave up? Well, we just need to make sure when x is 0, that y is not 0. So if we look down here at our final work, if x is 0, y is not 0. In fact, y could never be 0. So it definitely must be concave up. So I'm just showing how like the differential equation can fit together, and we can ask questions around a lot of the topics that we've asked this year, all in this context of the differential equation. Okay.